Now this will feel very familiar to our first game that we played with the 3 doors and the goats in the car and everything like that. It's going to be basically exactly the same kind of code, but let's do it again. What we really want, if you remember right, if I save this code and you see the default, well, now it's not going to give it to me, is it? I'm going to click the console. Sometimes that seems to reset it. There we go. Okay. Notice this is kind of the format I wanted. I wanted the number of wins as well as a percentage. So let's actually do that. So let's compute the percent wins first. Let percent wins equal, something. In this case, what is it? It's the number of wins divided by the number of iterations, right? If there was 5,000 wins and 10,000 iterations, 5,000 divided by 10,000 is 0.5. And then you multiply by 100, of course, to get a percentage, 50%. If it was 2,500 out of 10,000, then it would be 0.25 times 100, 25%. So let's do that. Number of wins, I'm going to put this in brackets or parentheses, divided by number of iterations, times 100 to get into a percent. So that just does the math for me. How many times did I win divided by how many times did I try? That's a fraction between 0 and 1, multiplied by 100 to get a percent. Now that is a fraction. It might be like, if I just do percent wins here rather than number of wins. So I'm just going to show this here. Let's click run, and let's do a smaller number of students here. Notice there's these really long, obnoxious decimals on this, which is not horribly useful, right? Some of these are short, but then sometimes they're long. This has to do with computer math. Anytime you have fractions, again, I believe we talked about this, but like anytime you have fractions, there's like slight inconsistencies because computers can't do infinitely long decimals. They have a finite number of decimals in them. They truncate things. They do math. Things get slightly off, and you get really silly things like this, which is almost certainly 3.41, but here shows up as 3.40999, lots of 97. That looks dumb. Let's fix that. So usually the way to fix that is just to round, right? So let's actually just say percent wins equals percent wins dot. This is a function that JavaScript provides, dot to fixed 2 decimal places. So this says, don't give me this crazy long thing, round this thing out to 2 decimal places, basically. Now notice it's working much better. Oh, well, I got to change my number back to 4 here or else I'm not going to see anything. But notice I'm getting 2 decimal places only. Excellent. If I do 3, then I would get 3 decimal places. Whoops. Well, I will as soon as, well, you can see 3 decimal places here, but you can see 3 real decimal places here too. Now, you might be a little freaked out by this. Why is this always 0? It's because if you remember right, we're only doing 10,000 iterations. There are only between 0 and 10,000 wins. If you think about it, if there were 9,999 wins and you divide that by 10,000, there's only 4 decimal places there, right? 0.9999. Here we're getting 3, like 0.396. We got 396 wins out of 10,000, which is why it's 3.960%. I haven't actually added the percent on the end of this in the text, but we will do that shortly. Notice I just don't have enough accuracy again because I'm not running enough iterations. If I increase the number of iterations, I start to have better accuracy. So again, this is what Monte Carlo does for us. So I'm going to change this back to 2, and let's actually make our text look right. I want to actually show the number of wins as well as the percentage, just like this shows. So that's going to be my last thing here. I'm going to come down here and say, I want to actually show num wins. And then I'm going to add to that a string with an open bracket here. So this is, again, num wins. And notice I put a space as well as a bracket in there. That's this space and this bracket. Then I'm going to add in my percent wins, right? So let's just put a plus percent wins here. Notice that even though these are both numbers, because there's a string in between them, the second the computer sees a number plus a string, it converts the whole thing into a string. It knows that's the only thing it can do with it. So we're just using that to our advantage, possibly abusing to our advantage. Anyway, plus percent wins. Notice I still need my percentage sign on the end, so I'd better add that. Plus percent and close bracket. And that's it. So let's actually run this now. I'm going to change this back to 4. And notice it's actually doing what I asked it to. Now, it's really boring because, I could have figured this out myself. 390 out of 10,000 is probably at 3.90%. But if this gets more complicated, like I want to only do 2,500 runs, we're actually kind of grateful that it's computing the percentage chance here. Same if I was like, I want to do 3 million runs. I'm like, oh, wow, I'm really glad it computed the percentage for me there. That would have been a little harder for me to do in my head. Probably can't. But yeah, I got 109,753 wins, which is a 3.66% win rate. So perfect. We've actually got our game running. And it's running well. Like we can change the number of students. We can change the Monte Carlo runs and see, roughly people winning a certain percentage of the time. Notice even at the number of students being 6, how low of a chance there is for these students to win with the random strategy. Again, remember that means no memory. That means that poor child might go in there, pick, or adult in a university setting, obviously, but like they might go in there and just pick the box 1 like 3 times in a row. That would be very depressing. So we are going to have to fix that. We're going to fix one more thing before we end this part, though. So what I want to fix last here is that there's really no nice way of telling the user that a calculation is taking a long time. So if I up this to 3 million, the only thing I have right now that tells me whether it's done is I click the run button. Notice it's a lighter gray, and it eventually becomes a darker gray. And this text did change because it was the default text. I'm going to click run again. And notice I'm really only paying attention to this light gray. And dark gray eventually comes back, but notice the text didn't change, and so that's really subtle as to like, are you still working? Should I wait for you? Are you done? Especially as the number of iterations gets higher, this becomes a problem. So I would love to show a calculating message here, and then just have it be done, like show the number when it's done. So I'm going to fix 2 things here. I'm going to remove this, just for nicety, again, for presentation. We don't need to see the number, like a false number of wins when we start the game. So there we go. Wins is blank now. That was, again, somewhat separate, but just I don't need that anymore. And the second thing I want to do is down here, and probably after I do my error checking and I know I'm about to start calculating things, I would like to set that wins tag, that text, just like I set it down here. Wins tag.innerHTML. Wins tag.innerHTML. Did I get the capitalization right? Yes. Wins tag.innerHTML. Inner is lowercase, HTML is uppercase. Tag is capital T, and that's it. And I'm going to say equals calculating. Oh, this would be so beautiful if this worked, but it doesn't. Okay, so I click 3 million, run, and it still doesn't put my calculating text in there. I'm sad. Why not? Why is this not working? What's interesting is if you go down here and just comment this line out, //. So I only set wins tag inner HTML to calculating and then go do, 5 seconds of calculation. Huh. Okay, well, that worked because that wasn't fair. I didn't type in my 3 million here. Let me bring up the console again and let it reset. There we go. 3 million. You notice it was working, right? It brings up calculating. I click run. Yay, calculating eventually shows up. What's going on here? I clearly set calculating. It is working because I see it. And I set it before I do any of my main for loop here, right? This is the for loop where I create random boxes, 3 million times in this case, play a game, increase the number of wins, etc. So why did it not update this until the end? And the answer is because of how JavaScript and browsers work. The idea is that while JavaScript is running, in general, the browser is not bothering to what's called repaint the screen, basically to show you the changes. This is an efficiency thing. It's also, in animations, JavaScript animations, you want to be really careful about when you update the screen. All of this to say that basically while your JavaScript code is running, the screen in general does not update. So you're screaming into the void here by saying wins tag inner HTML equals calculating. It's like, gotcha, we'll do that on the next screen refresh. And then it does all of its work, comes to the end, finishes all of your code, your function, it ends, and then it's like, okay, doing those updates for you. I already overwrote calculating with the answer. This line was effectively useless because it didn't actually bother to repaint or refresh the screen until it was done. Yay. There are a few ways that you can handle this. One that I found at least works, it's a bit obnoxious, but at least it works, is called request animation frame. This is useful in JavaScript animations, and it would be really cool if I could just call request animation frame here. I would love that. Unfortunately, it's not how the function works. You have to give it another function name in here. Function name, whatever that is. So what this function does is says, I know you're going to repaint the screen at some point. I want you to make sure to call this function before you update the display. So I want you to make sure you've called this. Then you can go update your display and then continue on with your life. How are we going to use that? It'd be really nice if it was like, go do this function. Yeah, like it is, go do this function and then repaint it, repaint the screen. So I think I need a function with this in there, right? That would be handy. Let's go do that. I'm going to actually cut both of these out. And put them up here. Function run first. I'm going to call this function just something that I want to do at the very beginning. Wins tag inner HTML equals calculating. You'll notice that wins tag is a variable I defined here. I'm going to need that variable too if I'm going to use it from a different function. So I either need to paste this in here or move this to be a global variable up here. Either way works. I'm just going to leave this duplicated here for the moment. That's fine because I do still need it down here, right? I need wins tag in my run function and in my run first function. And now I'm going to link this function here to run. So this might seem slightly weird at first, and it's still not going to work, by the way, because I'm not done yet. But what this is saying is, and I should do one more thing here real quick, just so I can at least show what this is doing. Run first is actually what I want to call now when I click the run button. So when I click the run button, it's going to actually run this code, wins inner HTML, right? Wins tag inner HTML equals calculate. Then please run this function before repainting this frame. Not quite what I wanted, right? But it does get me halfway there. Because notice what this is going to do is I click the button, it runs this function, and then it also runs the run function before it repaints the screen. Yay. So if you do try this, it doesn't work because it actually runs all of your code again before it actually repaints the screen, so you never see calculating. But if we schedule another request animation frame, it will work. What do I mean by that? Well, we go up here and we say request animation frame run first. And you don't use the brackets this time. You just hand it the function name. Now, when I do 3 million, it does work. So it says calculating for a while. Oops, I actually hit the button twice, so you saw it blink there for a second, possibly. It's 0. Calculating and 0. Why is that working? Okay, so here's what this actually does. Request animation frame says, make sure you run the run first function right before the repaint, like literally right before you're about to do it. So that goes and actually schedules your code to run. And the screen is normally refreshing fairly fast. So this will happen almost instantly. So even though you click the button and then it's like, well, actually schedule this for the next repaint. The next repaint's coming faster than your eye can blink generally, or at least decently fast. And it'll be fine. It'll happen nearly instantaneously. So now it runs your code. Wins tag. You define it. You set the inner H2L to calculating. And then it says, now I want you to schedule run right before the next animation, like right before the next repaint, the next animation frame. It can't be the same one. It refuses to run your run function right now. It actually schedules it to the next one. So this gets us the separation we wanted. Weird. But run first runs right before the first paint is going to happen of the screen, the refresh. And this schedules the run function right before the next one. So this means that you'll get that repaint in between setting calculating and actually running your run function. I find that a little bit obtuse, but the short rule of thumb is you run this twice and it does what you want. And you separate it with these functions, like 2 different functions this way, it all works. There may be better ways to do this. I tried several. They didn't work great. This worked very consistently, so I'm going with this. So now we have what we want. We have a calculating message when we need it. Of course, if you just run really short, notice you see that little, calculating for a second and then it actually works. So you actually know it's maybe doing something, but it doesn't take long enough for it to actually matter. And you still do get, like you see again, it says calculating for a second, but then it still shows you the right percentage. And that's it. We have our game. It works. It even is kind of nice and showing people when it's running for a long time. So from here on in, we're just going to be doing refinements to the strategy to see the better ways that we can actually have students pick boxes. And that'll be on the next part. So until then, have a good time. Bye.